Alright, let's talk about copying arrays. If you have two arrays, how could we copy one into the other? This is quite easy in processing, and it's pretty much like copying variables. So if you have int a and you had int b, a is 5, b is 10, and let's say we have int r new int 3, and let's say we have int data 5, 6, and 7. So the memory diagram for all of this will look like we have A and B, we have R, which is 3 cells filled with zeros, that's 0, 1, and 2, and we have data, which contains 5, 6, and 7. So now if I went ahead and I said A equals B, sorry, this is, I assign the value of B to A, this means you assign the value of B to A or copy B into A. So now the value of A is going to be the same as B, the value of A is also going to be 10. Now if I went ahead and I said R equal data, that means copy the value of data into R. So what happens is the value of R, which is this array, is going to disappear. It's going to be thrown in the garbage, really. So we forget that it exists, and a new array is formed. So and then data is copied into R, so R becomes 5, 6, and 7. So that's how copying works. The key is these arrays need to be the same type. So, for example, we have arrays A, it's filled with hundreds. We have array B, it has 4 cells, each cell contains a 0, and we have a double array C that has 4 elements in they each contain 0. So here B and A are the same kind, so we could copy A into B or B into A. That's completely legal, but we cannot do this because you cannot copy an array of integer into an array of double and vice versa. A question is that what if the two arrays were different sizes? No problem at all. So if you have two arrays, one is A, the size over here is, so the length of the array is 5, and over here the length of array B is 3. If you copy A into B, so before assignment, B in memory looks like this, A in memory looks like this. When you do the assignment, when you assign A to B, what happens is B is going to become A. So you're actually copying A into B. So what happens is the old B is going to disappear because you're copying over it, and it's going to have more value. It's going to have more cells, and the cells are going to be exactly the same as A. Now, suppose you had two arrays, actually, let's do it here. Suppose you had two arrays and you had int r it's set to 11, 12, and 13, and you had int data set to new int 2. So essentially then you have r that is set to 11, 12, and 13, and you have data that is set like that. So if you go ahead and say, if you assign, for example, if you assign let's say if you said r and you assign that to data, what happens is r is going to be destroyed, so the old r doesn't exist anymore, and the new r, it's only going to have two cells. It's going to be a replica of data, exact copy, right? And of course, if you said data equals r, then data is going to become a replica of r. So we know that. I don't need to show it here. I think we know how that would work. But what if you wanted to copy as many elements as you can into data? So you don't want data to be the size of r. It's just that you want to copy maybe you want to copy the first as many elements as possible from r into data. So basically you want r to look like 11, so you want data to look like 11 and 12, and that's all you want. You don't actually want to overwrite it, or you don't want to change the size or anything. How would you do something like that? So with that, you actually have to do it using a loop, and you have to be very, very careful doing it. Meaning you would have to do something like this. So you would have to say for int I equals 0, because you want to go through both of these. I less than I plus plus. And less than what? And then you basically want to say copy. So you're copying into data. You want to say copy the ith element of r into the ith element of data. So you have to be very careful. The size of the array here, it has to be it has to be the size of the smallest is the smaller array. So data dot length. So here you have to have the size of the smaller array. Why is this? Well, if you think about it, if here we put the size of the larger array, then eventually you're going to be pointing, so eventually you're going to be looking at R index 2, and then you're trying to put R index 2 into data index 2, and you can't do that, right? Because of the simple fact that data only has 2 indices. So in this case, if you're trying to just copy one element at a time, you want to make sure to have the size of the smallest, the smaller array here. Let's just quickly show that in processing. We'll see what that actually looks like. So just starting it up, and maybe start up processing with me and experiment with this. A big part of programming is experimenting and seeing what works and what doesn't work. So let's say we have int R. Just quickly gonna type and then int data 11 and 12. And what I want to do, let's say I just want to copy as many as I can from R into data. So I need to say for int I equals 0, I less than the smallest of the two, which is data. It doesn't matter which one you're copying into which one. It just always has to be the smallest array that you look at the size. Dot length I plus plus. And of course here you simply say R, or I wanted to copy into data. So the ith element of R is being copied in the ith element of data. So if I print data, oh, I didn't put a semicolon here. Let's run it now. You see that it's been changed to 2 and 3. Now, see what happens if I use the length R. What happens? What kind of an error I would get if I said R dot length? I would get an out of bound exception error. So it's very, very important that you have this in here. All right, let's do an example involving an array of strings. So if we have string caller array names, and let's say we initialize a few names, so Sam, Joe, and let's say Bob. All right. So in memory, our array actually looks like this. This is index 0, index 1, index 2, and inside we actually have Sam, Joe, and Bob. But don't forget they're strings themselves, so it's almost like a two-dimensional data structure. So it actually ends up looking like this, sort of, because the strings have their own indices. And so this is 0, 1, and 2. And of course I used short names, so like I could have made long names, but it's auto coincidence that everything has index up to index 2. So this is what it will look like, right? So if I said, for example here, if I said print ln and I said print the second index of names, which is index 1, what would print out? Joe would print out, right? Now, I have a challenge for you, and I want you to maybe pause the video and try to answer this. What happens if I wanted only, for example, the M printout from Sam, like right there? What if I wanted that guy to print out? So I would say print ln name, and this is names. So names index 0 dot char at index 2, and this is going to print out M. You see, it's basically opening boxes. It's a box inside a box. So I need computers is all about addresses. So I've given this thing a couple of addresses. So I'm saying go to this array name called names and go to its index 0. So it'll go here. Then I said, so in there you're going to find a string. This is going to this names.0. This is a string, right? So I'm saying this is a string. When you have that string, then dot char at, if you say dot char at and then the second index, and it brings us here. So it's just like finding an address. Let's do another one. If I say print ln names index 1 dot char at 0, what is that going to print out? That's going to be names, okay, index 1, that's where we are, char at 0, so the second char, this is going to print out J. Really quickly, let's program something similar in processing, and that should make this very, very clear for everybody. So I'm just going to do a setup function. And let's do an array of strings. So we'll say string, call it names again. I'm missing my... This time let's just say new string. Let's say I'll request 5. And then I'll just say names index 0 Joe, names index 1 Mike with quotations around it. So it scared me for a second, but nothing is wrong. So if I come here and I say, okay, well, print me my array, and if I could just type, print me my array, it prints the entire thing. So it says in the first one you have Joe, in the second one you have Mike, and in the other 3 you have null. So this is not an array of integers, or it's not an array of numbers. So in the other 3 elements, in the other 3 indices, we have null. So if I say, for example, if I say here to print me index 0, Joe is printed. If I said index 0 dot char at, and I say char at, and let's say the first one, so this should print out O, and it does. And if I tell it to print out index 4, which is the last, or index 3, it's going to print out null because there's nothing there. If I tell it to print index 5, what happens? Our last index is 4, so we get out of bound exception error. So, and I could, for example, say name index 4, which is the last index, and I could say in the last index put Mohammed, and I run this. It's names, not name. And also I didn't change this, so I'm just going to say to print out the entire array. And so it's Joe, Mike, Noel, and Mohammed. So basically it looks like this, where you have Joe, Mike, Noel. And null is not a string, it's basically saying 0. And then Mohammed. And these all look, like strings, obviously, with their own indices. And this is index 0, 1, 2, 3, and 4. All right. Thank you.